How's it going? Fractions and decimals. Converting a decimal to a fraction or a mixed number. Number 1. If the decimal has a whole number in front of the decimal point, this will be the whole number part of the mixed number. Remember, a mixed number has a whole number and a proper fraction after it, and the proper fraction should always be reduced. Number 2. The digits to the right of the decimal point will be the numerator of the fraction. The place value of the last digit will be the denominator. So some examples. If the last digit is in the tens place, the denominator will be 10. If the last digit is in the hundreds place, the denominator will be 100. If the last digit is in the thousands place, the denominator will be 1,000. Reduce the fraction if possible. Always reduce. Even if the directions don't say to reduce, you need to reduce. If the directions just say simplify, then you should always reduce. Write the following as fractions or mixed numbers. Okay, so it's only a mixed number if there's a number in front of the decimal point. So here's our first example, 0.4. No number in front of the decimal point. There's no whole number. The 4 is going to be in the numerator. And then what's going to go in the denominator? In the denominator, well, what place is the 4 in? Because that's our last digit. The 4 is in the tens place, so we're going to put that 4 over 10. And then we can reduce that, divide them both by 2. So we get 2/5. Okay, 7.08. So the 7 is going to be the whole number in front. 8 is going to be in the numerator. And then what place is the 8 in? It's in the hundreds place. So the denominator is going to be 100. Okay, now just reduce the fraction. So we can divide both of them by 4. The 7 just stays in front of the whole fraction. So 7 and 2 20/5. Okay, this doesn't seem too bad, right? This is a relationship between decimals and fractions. Right now we're changing decimals to fractions, and then we'll change fractions to decimals. Okay, here's some problems. You might want to pause the video and work on it on your own, and then click on play when you're ready to see the worked out examples. Okay, 0.9, so that's going to be 9 over 10, and then that doesn't reduce. Okay, 11.2, the 11 stays in front of the decimal point. The 2 is the numerator. 10 is going to be in the denominator because the 2 is in the tens place. And then does that reduce? Yeah. Divide both numerator and denominator by 2. So don't forget the 1 on top. 11 and 1/5. Okay, next number will be 8.36. 8 is the whole number in front. 36 is the numerator. And then the denominator will be, well, what place is the 6 in? The 6 is in the hundreds place. We'll put it over 100. Does that reduce? Yeah, by 4. You can divide by 2 and then by 2 again, or you can divide by 4. So 8 and 9 20/5. Okay, this one doesn't have a whole number in front, so it'll be 55 over, well, the third place is the thousands place, so 55 over 1,000. Divide both numerator and denominator by 5. So 11 over 200. Okay, let's move on. Okay, now we're going to start writing fractions as decimals. Now, writing a fraction with the denominator is a power of 10 as a decimal. So these are only problems with the denominators like a 10 or a 100 or a 1,000. Then its decimal equivalent will have the same number of places as there are zeros. The last digit will be in the place value equal to the denominator. So if the denominator is 10, the last digit will be in the tenth place. If the denominator is 100, the last digit will be in the hundredths place. If the denominator is 1,000, the last digit will be in the thousandths place, etc. If there is a whole number in front of the fraction, then the whole number will be the same whole number in front of the decimal point. Okay, so our first example, 7/10. We're going to write this as a decimal. There's no whole number in front of the fraction, so in front of the decimal point we're going to put a 0, and the numerator is 7, and that's going to be in the tenth place because the denominator is 10. So 0.7. 4 3/100. The 4 will be in front of the decimal point. The 3 will be after the decimal point, and the 3 has to go in the hundredths place because that's the denominator. So if you put 4.3, that 3 will be in the tens place, so it's got to be 4.03. See, now the 3 is in the hundredths place. 4.3 would be incorrect. Okay, let's do these. Again, you might want to pause the video and work on your answers. Okay, the first one is 3/10. So 0.3. Second one is 7 and 9 over 100. 9 is the numerator, so that's going to be after the decimal point. And it's going to be in the hundredths place because the denominator is 100. So 7.09. Okay, 25 is going to go in front of the decimal point. 27 is going to go after the decimal point, and the 7 is going to go in the hundredths place. So 25.27. And the last one, 6 is going to go in front of the decimal point. 43 is going to go after the decimal point, but the 3 has to be in the thousandths place. So we have to put a 0 before the 4, so therefore the 3 is now in the thousandths place. If you don't have a 0, then the 3 is only in the hundredths place, and that would be incorrect. Okay, so now let's talk about fractions where the denominator is not a power of 10. First, we'll talk about terminating decimals and non-terminating decimals. Terminating decimals is any decimal whose ending digits do not continue indefinitely, but stop, and that is a terminating decimal. So if it ends, it's called a terminating decimal. Here's some examples. 0.35, 0.625, 7.81. These are all terminating decimals. Non-terminating decimals. The decimal equivalents of some fractions are called repeating decimals. A repeating decimal is a representation of a fraction in which its ending digits repeat indefinitely with a pattern. Here's some examples. 0.3333. See, that dot 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 just means it keeps going on forever. or 0.57, 57, 57, 57, dot, dot, dot. Keeps going on and on. This is called a non-terminating. It doesn't end. It does not terminate. Okay, so sometimes we're going to use repeating decimal bars to show that it keeps going on forever. We use a repeating decimal bar over the number or numbers that repeat to show that the pattern repeats over and over. So that 0.333, you just simply put a bar over the 3 to say that it keeps continuing. Or 0.45, a bar over the 4 and 5 to show that the 4 and 5 repeat. 4, 5, 4, 5, 4, 5. This last one, 0.7333, we only put a bar over the 3 because it's only the 3 that repeats. You wouldn't want to put the bar over the 7 because it's not 7373, it's just 7 and then 3's that repeat. Okay. Now, converting any fraction to a decimal. To convert a fraction to a decimal, rewrite as a long division problem with the denominator in front and the numerator inside the division box. The denominator goes first, numerator goes inside. Bottom number goes first, bottom first. Insert a decimal point after the last digit of the dividend, which is the numerator, and write at least one zero after the decimal point. You might actually have to use more zeros, but at least one zero. Divide using the same steps as dividing with decimals. Add zeros to the dividend until you arrive at a zero remainder, or until you start seeing a repetition to a pattern of digits in the quotient. So if you see a pattern, you could stop. If this goes on 3, 3, 3, 3, then stop. You know what happens. If you see 4, 5, 4, 5, 4, 5, then stop. So if a repeating pattern emerges, stop and write a line above the first set of repeating digits. Sorry, it should be a line, not an line. Okay. So convert 3/8 to a decimal. We're going to write it as a division problem. Denominator to numerator. So the bottom number goes first, and the top number goes inside. And I put some zeros, I just knew it was going to have 3 zeros after it, but just start putting some zeros as you need. There's no general rule about how many you're going to need. Put your decimal point straight up. Now start dividing 8 into 30 3 times. 8 into 60 7 times. 8 into 40 is 5 times. And that's it. It ended. It's a terminating decimal. So the answer is 0.375. Just remember, the bottom number goes first. Bottom first. 2/5. Okay, why don't you pause and try this one on your own. Okay. Denominator into numerator. 5 into 2. Bring your decimal point straight up. 5 goes into 24 times. Oh, that's it. It didn't have a remainder, so our answer is just 0.4. I didn't need all those zeros. And that's okay. No harm. Okay, so the answer was just 0.4. Let's move on. 7/11ths. 7 over 11. Use a repeating decimal bar if necessary. That's kind of a hint. We're probably going to need it. Alright, so let's divide it. Remember, second number first. Sorry. Denominator first. Denominator first. Bring your decimal point straight up and then start dividing. 11 into 70 is 6 times. 11 into 40, 3 times. 11 into 70. You know, that's how you know when it's going to repeat. When you start dividing into the very same number. See, we first started dividing into 70. And now we're dividing into 70 again. That's when you know it's going to be a repeating pattern. Okay, so let's keep going a little bit more just to see. 11 times 6 is 66. 11 to 40. See, there it is. It just keeps going on. 63, 63. So we're just going to put a bar over the 6 and 3. And we're all done. Okay, 2/9. Let's try this one. Pause the video and work on it. Okay, which number goes first? Right, the 9. 9 times 2 is 18. Oh, same pattern again, right? 2, 18. We keep going on and on. So what's our answer? 0. You only have to put the bar over the first 2, so 0.2 with a bar over it. Okay, that was our last problem. I'll see you here for the next video. Have a good day.